Okay, so we are starting on the topic of quadratic and cubic equations with complex roots. So we will firstly do solving quadratic equations, finding the roots, and then working our way back just to see the process forward and in reverse. So the first thing we're doing is finding the roots of a quadratic equation. It is x squared plus x minus 20 equals 0. So the first step you should do here is say, can I factorize this? Yes, you can. So factors of negative 20, which add up to positive 1, or factors of 20, which minus to give you 1, 4 and 5. So this can be factorized into 4 plus, since it's plus x, it'll be 4 plus 5 into x minus 4 equals 0. So moving on from there, you go x plus 5 equals 0. Why? Because you're using the null factor law to find your roots. So here x is equal to negative 5 and x equals 4. So these are your solutions. They can be written in the form x is equal to negative 5 and 4 within curly brackets, showing that this is the solution to the equation. What you have done essentially is found the roots of a quadratic. Now, if I was to give you the roots of the quadratic, so for example, I'm going to use the same equation so you can see the reverse process. So if you have a function of x squared plus bx plus c equals 0, a is, let's say, 1, and I've given you the roots of negative 5 and 4, how can I go from here back to the original equation? So this is one way of doing it. And if you, for example, if you go and rewrite the roots in terms of what x is equal to, for example, x equals negative 5 and x equals 4. Take the next step back, which is put the negative 5 to the left. You get x plus 5 equals 0 and x minus 4 equals 0. And then you can put them in the brackets of x plus a times x plus b equals 0, which is x plus 5 into x minus 4 equals 0. And have we actually found the original equation? No, we haven't. So the next step normally we do is we expand it and ask and simplify. So if you expand that, you end up with x squared plus x minus 20 equals 0. And that is your original equation. So what have we done? In the second part here, we have essentially been given roots, and you've used the roots and found the original function or original equation which you were to solve. So we have done one example with the quadratic. Now let's see if we can try one with the cubic. Right, so on page 105, on example number 2, or second example, it says solve the cubic equation x cubed plus x squared minus 2 equals 0. So using the factor theorem, you can find the first a root of this equation. So we're actually solving. We're finding the roots here. So how are we doing that? Well, factor theorem. So if you substitute 1, let's say, x equals 1. In here, you end up with 1 plus 1 minus 2 equals 0. Yeah, it is equal to 0. Therefore, f of 1 equals 0 means x minus 1 is a factor. Right. So what we can do next is we can do long division. Yeah. So x cubed plus x squared minus 2 equals, divided by, maybe I should write it, hang on. So we can divide the original function of x cubed plus x squared minus 2 with x minus 1 and see how we can, well, to get a remainder, to get a quadratic, and see how if we can factorize that. So step 1, just be careful because there's no x term. You might get tripped up in the middle. So I'm going to change the color just to show some differentiation. Okay, so 1 multiplied by x would give you x cubed, it will be x squared. So you go x squared, then times it by x, you get x cubed. Then minus 1 times x squared is minus x squared, rule off, and minus. X cubed disappears, you get x squared, minus x squared will be 2x squared. And then, I haven't brought down minus 2 yet. So, what multiplied by x will give you 2x squared will be plus 2x. So 2x times x is 2x squared. And then if you multiply 2x by negative 1, you get minus 2x. Right. Now you minus. So, you will see from there that 2x squared will cancel. And minus 2x will stay because there's a 0 here, simply because there's no x terms. So you end up with minus 2x will be positive 2x. So it will be 2x. And then you bring the negative 2 down, you get minus 2. So what times x is 2x? It will be plus 2. So 2 times x would be 2x. 2 times negative 1 will be minus 2, and if you rule off, you'll end up with 0 as your remainder. Therefore, this function can be written as, which is x minus 1 times x squared plus 2x plus 2. Okay. Right, so for us to be able to find the roots of this question, what we do next is see if you can factorize this quadratic. You can't, because the factors of 2 are 1 and 2, and 1 and 2 don't add up to 2. Therefore, the next step from there is a quadratic formula, or you can just use your graphics calculator. If it's fancy, then you will be able to get a complex solution. But if you were to use the quadratic formula, then you got a is equal to 1, b is equal to 2, and c equals 2. Right, so x would be equal to minus b, which is minus 2, plus or minus square root of b squared, which is 4, minus 4 times 1 times 2 is 8, over 2 times a is 2. So if you simplify this further, you get minus 2 plus minus, I'll miss a step here. Square root of 4 minus 8 is square root of negative 4 is square root of 4 times negative 1, which is square root of 4 times I, which is 2I over 2. And then if you take 2 out, or separate them, minus 2 over 2 plus minus 2I over 2, you end up with minus 1 plus minus I, which gives you minus 1 plus I and minus 1 minus I. Therefore, your roots for the function are, if you were to solve it, you'll have to do this bit here first, which is x equals 1, right here, from here. That x minus 1 equals 0, x equals 1. So your solution would then be x equals 1 and the ones above here. So you've got your 3 roots. Cool. All right, let's see what we can do with that. Okay, so the next question is the roots of an equation are x equals negative 4 and x equals 3 plus 2i. So you are given roots of a, actually should be of a cubic, hang on, let me. Right, so the roots of a cubic are x equals negative 4 and x equals 3 plus 2i. If you are given a complex root, then the conjugate of that would be a root as well, meaning if you were to label them x1, x2, x3, then x1 equals negative 4, x2 equals 3 plus 2i, and x3 would be equal to the conjugate of 3 plus 2i, which is 3 minus 2i. Now the thing is, we have the roots, easy, but how do we go about finding the original solution? So from the first one, the x1, change the color slightly. So from x1 equals negative 4, we can rewrite this as a null factor law, which would be x plus 4 equals 0. So one of the things that actually is quite important in this these steps are you have to be able to use, because we're using conjugates, we have to be able to use difference of squares quite fluently. That is, for example, a plus b times a minus b is equal to a squared minus b squared. Now, if you were to proceed with the conjugate, so we already know that x plus 4 is a factor. Let's see if we can figure out how to go about doing the complex number scenarios. So just like we have got x plus 4 equals 0 as a factor, for the complex we can use x minus 3 plus 2i times x minus 3 minus 2i. And if we expand this, because that's a factor, it's like x minus a times x minus b times x minus c. So if we expand this, we should be able to get the, if you go back, we should be able to get this bit here. So what do we do to expand this in an efficient form? This right here, this expression is difference of square. As you can see, a plus b times a minus b, x minus a times x minus, x minus a times x minus b. But when you multiply 3 plus 2i times 3 minus 2i, you can just use the difference of square. So let's see. So if I just change color. So if I multiply x with x, I get x square. Then I multiply that x with 3 minus 2i. Sorry, my bad. What we do next actually is, sorry, just give me a sec. Take that out. Okay, so what we do next is we collect the real components and the imaginary components by opening the inside brackets. We end up with x minus 3 minus 2i times x minus 3 plus 2i. And here you will note that you can now bracket them according to real and imaginary components. So it's x minus 3 minus 2i times x minus 3 plus 2i. Now we can use the difference of squares in a much more effective way. So x minus 3 times x minus 3 is x minus 3 squared, which is perfect square. Then you go x minus 3 times plus 2i plus minus 2i times x minus 3. The middle terms will drop and you end up with minus, what's 2i squared? 2i squared would be equal to 4 times negative 1, which is negative 4. So minus 4 would be plus 4. So if you expand x minus 3 squared, you end up with x squared minus 6x plus 9 plus 4. And so 9 plus 4 gives you 13. So you end up with x squared minus 6x plus 13. And that becomes your the quadratic extra, because you already have x plus 4. So your function f of x would be equal to x plus 4 from here, and then multiplied by what you just got, which is x squared minus 6x plus 13. And then if you multiply x times x square, let's change color, x times x square would be x cubed minus 6x square plus 13x plus 4x square minus 24x plus 52. I think 13 times 4 is 52. So if you collect the x square terms, you end up with x cubed, and then minus 6 plus 4 will be minus 2x square. That cancels, plus 13 minus 24 would give you minus 11x, and then plus 52, and then you can see that you have a cubic function of the form ax cubed plus bx squared plus cx plus d. You were given the real root and one of the imaginary roots. Therefore, you found the other imaginary root, which is a conjugate. You multiplied the two conjugates together, simplified it, and got a quadratic, and then you multiplied all of them to find the cubic. And that is how you find the root of a cubic given. Sorry, that's how you find the equation of a cubic given the roots.